Find the inverse of the function below and circle your final answers. We have 6 to practice. Remember, whatever you see in f of x, it's really like a y. When you find the inverse, I'm going to replace the x and y. And now I want to isolate the y. So the first thing I'm going to do is divide both sides by the 3 in front. So I have x over 3 equals log base 5 of y. Notice there's already a log within this function. So to get rid of the log, I'm going to look at whatever the base of the log is. It happens to be the numerical value of 5. And now I'm going to make this the base and this the exponent. Base exponent, base exponent. Now on the right, cancels. I bring down the y. Y equals 5 raised to the x over 3. This problem was originally f of x, so inverse of f is equal to 5 raised to the x over 3. Alright, I'm going to flip into e and then come back to it. Now, the reason I'm doing that is notice that this had a log in it, the original problem, this does not. And so I'm going to go back and forth here. So the f of x, which is like a y, okay, I'm going to switch the x and y. And now, how do I eliminate the 3 so the y comes down? I'm going to place a log. I'm going to place a log of the numerical value I'm trying to get rid of on both sides. Then bring down what was already there. On the right-hand side, log base 3 and 3 cancel, and I get to bring down the y. Log base 3 of x. This is not an exponent, but at the same level. The original problem didn't have a log in, now it does. The original problem did have a log in, now it doesn't. So the inverse of f of x is equal to log base 3 of x. Back to problem B. Notice that this is log base 3 of x, and then subtracting 2 is behind it. So I'm going to switch the x and y to start with. So to isolate the y, I'm going to start by adding 2 to the opposite side. Again, notice this problem had a log in it. So to eliminate the log base 3, I'm going to take whatever the numerical value is. It becomes the base exponent. Base exponent. And this original problem is f of x. Let's go to a problem that does not have an the original problem does not have a log in it. Switch the x and y. Now to isolate the y, I'm going to do log base 5 on both sides. And write down everything that was there. On the right it cancels. I have y minus 1 equals log base 5 of x. Now, take this 1 and add it to the opposite side. I get log base 5 of x plus 1 equals y. And remember, this y is really f of x. Now, why did I put parentheses around this? Because I don't want you to assume the x goes, the 1 goes with the x. I'm going to add that from this original part of the function. Did not have a log in it, now it has a log. Did not have a log, now it has a log. Had a log, no log, but has an exponent. Had a log, no log, but an exponent. Keep that in mind. You may be thinking, well, does this have a log? Remember, ln is the same as log base e. So I'm going to start by switching the x and y and changing ln to log base e. This time it specifically shows us that the x minus 7 is part of the log base e, so it has parentheses around it. I'm going to divide by 4 to both sides. I'll do the it stands out here. Notice that the original problem does have a log in it, so I want to get rid of the log base e. So I look at the numerical value of e, base exponent, base exponent. So I have e raised to the x over 4 equals y minus 7. I'm going to add 7 to the opposite side. And then notice the original problem was y. Here's the inverse of y. Similar to option C, the original problem does have a log, and notice that when it has a log, I'll find the inverse, but the answer, the inverse, does not have a log, it has an exponent instead. So let's switch the x and y. X equals log base e of y plus 4 plus 2. I'm going to subtract 2 to the opposite side. And then to get rid of log base e, I'm going to put e in the bottom and above. E on the bottom and above. Y plus 4 equals e to x minus 2. To isolate the y, I'm going to move a positive 4 to the opposite side by subtracting it. E to the x minus 2, all subtract 4 equals y. Inverse of y shown.